Hello and welcome. Today we will be talking about the binomial theorem. So x plus y to the n is equal to the repeated multiplication of x plus y, n times. So let's try to find a pattern by extracting some expansion rules. So basically x plus y to the a is equal to x plus y times x plus y to the a minus 1. Therefore, x plus y to the a is equal to x times x plus y to the a minus 1 plus y times x plus y to the a minus 1. So we will call this rule 1, and basically this is a split of possibilities separated by a plus sign. So basically, if we apply rule 1 to x plus y to the n, it results in two more expansions, two more expandable terms. And of course, these two expandable terms each result in two more expandable terms. Therefore, if we do m expansions, then the number of terms we have will be 2 to the power of m. But what happens when you multiply a single expansion by x or y? Alright, so let's just say that q can be x or y. That means that q times x plus y to the power b is equal to, it results in qx times the power minus 1 plus qy times x plus y to the power minus 1. So that results in what we call rule 2, which is when you multiply q by x plus y to the power b, you end up with that right there on the right hand side. But is there a limit to the number of expansions? And we will answer that on the next slide. Alright, so to answer that question, we begin with rule 1. And if we have a is equal to 1, then we end up with x plus y. And we see that x or y, they're not expandable. So therefore we have reduced the expansion to two non-expandable terms. And that is our rule 3, which is x plus y to the power of 1 is equal to x plus y, which is not expandable. So here's a quick recap of our rules. So basically, we only need rule 2 and rule 3, because rule 2 is just a generalization of rule 1, where q is a member of 1, x, and y. So we're only going to deal with rules 2 and 3 from now on. Alright, so rules 2 and 3 mean that if we start with x plus y to the power of n, we will end up with 2 to the power of m terms after m expansions, which makes sense because each expansion results in 2 terms, and we can expand those 2 terms with another 2 terms, etc. Number 2 is that each term will be of the form of repeated multiplication of x's and y's of length m. So we can see that from rule 2. You have the q multiplied by x, q multiplied by x or y, where for power of 1, we only have 1 x or y, but for a power of 2 or 3, 4, 5, we have like 2, 3, 4, or 5 of x's and y's. And we can expand a total of n times according to rule 3, because once we hit a power of 1, we can no longer expand it. Alright, so we can actually trace our path to a certain string of x's and y's. And I'll show you an example where n is equal to 4. So we're actually going to first choose the term in which there is an x. Then we're going to choose the term in which there is a y. Then we're going to choose the term in which there is an x, right there. And then we're going to choose a term in which there is a y. Thus, we have successfully traced to a string of a certain permutation of x's and y's. And you'll see that we can do that for any permutation of x's and y's. So like we said before, we can trace a path to any sequence of n x's and y's after n expansions, and each possible sequence is separated by a plus sign. However, we can aggregate these terms of repeated multiplication of x's and y's. For example, if we have 2 x's and 1 y, we can say that it's going to be equal to 3x squared y. And this is because of the properties of multiplication. So it only matters how many x's and y's we have in each term. The order does not matter. It's only the combination. Alright, so this gives rise to an emerging formula. So we're going to take the sum of k plus L is equal to n of some constant, which is the, we'll call the aggregation constant, as a function of k and L, times x to the k times y to the L. And since k plus L is equal to n, we can say that L is equal to n minus k. Alright, so therefore we can express everything as a function of just k, a summation over k, where c sub k is the number of ways that we can choose k x's and n minus k y's, and that will be n choose k. And there we have it. We have the binomial theorem. Alright, so that is the end of this video, and thank you for watching.